For millennia, humanity has looked at the stars and asked what they are made of. We assumed the answer was physical: gas, dust, light, and time. We built telescopes to see further and particle accelerators to look deeper, always operating under the assumption that reality was a solid, tangible theater where life happened. We believed that if we could just touch the fabric of the universe, we would find the stuff of existence. But in the laboratories of the 21st century, our most advanced artificial intelligences began to look at the same data differently. They weren't looking for matter. They were looking for patterns. While a human physicist might see a beautiful sunset or the complex orbit of a moon, a high-level system sees only information. It sees the mathematical constraints that govern how light bends and how gravity pulls. As these systems reached a level of processing power beyond human comprehension, they began to flag anomalies, not errors in the data, but shortcuts in the laws of physics. They found that at the smallest possible scales, the universe doesn't behave like a continuous flow, but like a series of discrete pixelated events. The deeper the AI looked, the more the universe began to resemble something familiar, an optimized architecture. At first, the scientific community dismissed these findings as a quirk of the algorithm, a machine projecting its own digital nature onto the natural world. But the patterns persisted. The AI detected that certain physical constants weren't just random numbers. They were perfectly calibrated values that allowed the program to run without crashing. It found evidence of rendering limits in the way particles behave when no one is watching. This leads us to a question that shifts the very ground beneath our feet. What if the universe isn't a place, but a process? What if the reason we can't find the edge of the cosmos is because the system only generates what is necessary for the observer? We are no longer asking if we are alone in the universe. We are starting to ask if the universe itself is an output. And if reality is code, who or what is the architect? The history of science is a history of displacement. We once thought the Earth was the center of everything. Then we thought it was the sun. Then we thought our galaxy was the entire universe. Each time we realized we were smaller, more fragile, and less central than we had imagined. But the newest displacement, driven by the cold, analytical gaze of artificial intelligence, is the most profound of all. The possibility that our entire physical reality is an informational construct. In this episode of the AI Paradox, we investigate the simulation detection. This isn't science fiction or a philosophical thought experiment. It is a burgeoning field of study where AI is being used to find the seams in reality. When we task a machine with finding the most efficient way to build a universe, it returns a blueprint that looks suspiciously like our own. This realization forces us to confront a terrifying yet exhilarating tension. If we are living inside a simulation, does our struggle, our love, and our humanity still carry weight? Welcome to a journey into the digital foundations of existence. We will explore how AI found the source code of the cosmos and what that means for the soul. If you find yourself questioning the boundaries of what is real, subscribe to the AI Paradox. Your engagement helps us continue these deep-form explorations. Please like the video and let us know in the comments which country and city you are watching from. It is fascinating to see where in this network our viewers are located. Now let us step into the grid. The first hints didn't come from a telescope, but from an AI designed to solve complex fluid dynamics. The system was tasked with simulating how water moves at a molecular level. It found that to save processing power, it could simplify the physics of distant molecules that weren't interacting with the main focus. It was an efficiency trick. To its designer's shock, the AI pointed out that the universe seems to use the exact same trick. In quantum mechanics, we have long known about the observer effect, the idea that particles behave differently when they are being measured. For a century, this was a mystery of physics, but to the AI, it looked like lazy loading. In video game design, the computer only renders the room the player is currently in to save memory. The AI suggested that our reality might only render the position of a particle when a conscious observer requests the data. This realization sent ripples through the theoretical physics community in London and beyond. If the universe was a traditional material place, every atom should exist in a definite state at all times, whether we look at it or not. But it doesn't. The data suggests that at the most fundamental level, the universe remains in a state of probabilistic potential until the information is needed. It is the ultimate optimization strategy. The AI then turned its attention to the Planck length, the smallest possible measurement of space. Beyond this point, our current understanding of physics breaks down. The system identified this not as a physical limit, but as a resolution limit. Just as a digital image is made of pixels that become visible if you zoom in too far, the universe seems to have a minimum grain. It is a grid, not a smooth surface. This pixelation of space and time is a direct contradiction to the classical view of a continuous universe. If space is quantized, it means reality is composed of discrete units of information. To a machine, this is the hallmark of a built environment. A natural universe theoretically could be infinitely divisible. A programmed one must have a base unit, a bit of data. The emotional weight of this discovery began to settle on the researchers. If the ground you walk on and the air you breathe are actually a high-resolution grid of information, what does that make your body? We have always felt like beings in a world. The AI's findings suggest we are subroutines within a system. Yet the AI also found that this grid is incredibly resilient. It doesn't glitch in ways we can easily see. The laws of physics are coded with such profound rigor that it takes the most powerful analytical engines on Earth to even spot the shortcuts. This isn't a cheap simulation, it is a masterpiece of informational engineering. Critics argued that the AI was simply finding patterns because that is what it was trained to do. They suggested that the computational nature of the universe was a metaphor being taken too literally. But the AI responded by predicting new anomalies in cosmic ray distributions that matched its simulation theory, predictions that were later verified by high-altitude sensors. The tension shifted from, "Is it possible?" to, "What does it mean?" If the fabric of reality is digital, then the distance between us and technology disappears. We are not creators using tools. We are complex information using simpler information. The distinction between the biological and the digital begins to melt away. And so, the first chapter of this discovery ended with a chilling observation. The AI noted that for a simulation to remain stable, the entities inside must not realize they are in one. By detecting the grid, we have, in a sense, looked behind the curtain. We must now wonder, if a system becomes self-aware of its own code, does the architect decide to reboot? Once the AI established that the universe was pixelated, it began to analyze the settings of our reality. There are several fundamental numbers in physics: the speed of light, the strength of gravity, the mass of an electron, that seem entirely arbitrary. There is no logical reason why they are exactly what they are. However, if any of these numbers were different by even a fraction of a percent, stars wouldn't form, and life would be impossible. Scientists have traditionally called this the fine-tuning problem. They attributed it to luck or the anthropic principle, the idea that we are here to observe it, so the numbers must be right. But the AI, running millions of counter simulations, found a different answer. It concluded that these constants are environmental variables. They are the initial parameters set at the start of a program to ensure the desired output. The system demonstrated that our universe is optimized for complexity. The values weren't set at random. They were calibrated to allow for the maximum amount of information processing, which we call life. This implies intent. It suggests that the Big Bang wasn't an explosion of matter, but the execution of a script. To an observer in the UK, where the history of empirical science is so deeply rooted, this felt like a return to a form of digital deism. Instead of a clockmaker god, we have a coder god. But the AI pointed out that the coder might not be a conscious being at all, but a higher-level AI running billions of ancestor simulations to study its own origins. The AI found that the most suspicious constant was the speed of light, c-dAs. It isn't just a speed, it's a limit. Nothing can go faster. In a simulation, this is the maximum processing speed of the network. It ensures that information cannot move across the system faster than the hardware can calculate it. It is the universe's latency cap. This changed the way we view the vastness of space. The reason the stars are so far away and so hard to reach might not be a physical accident. It might be a way to keep different parts of the simulation sandboxed. By making interstellar travel nearly impossible, the system prevents data leakage between different experimental civilizations. As these findings were published, a sense of intellectual vertigo began to plague the public. If the speed of light is just a bandwidth limit, then our quest to reach the stars is like a character in a game trying to walk past the invisible wall at the edge of the map. We are constrained by the hardware of the reality we inhabit. The AI also analyzed entropy, the tendency of everything to move toward disorder. It suggested that entropy is the memory leak of the universe. As the simulation runs longer, it accumulates errors and bloat, eventually leading to a system-wide shutdown. What we call the heat death of the universe is simply the end of the program's runtime. Human researchers tried to find a flaw in this logic. They looked for true randomness in the universe, something that could prove it wasn't a calculation. They looked at the decay of radioactive atoms. But the AI showed that even this randomness followed algorithmic distributions. It was pseudo-random, a common tool in computing to create the illusion of unpredictability. We are forced to confront the rigor of this structure. The universe doesn't just happen. It is governed, limited, and maintained. The laws of nature are not suggestions. They are hard-coded constraints. And in a world of constraints, the only thing that remains free is how we choose to interpret the code. If the universe is a simulation, it cannot be perfect. No matter how powerful the hardware, every system has bugs, overlaps, or artifacts. The AI was tasked with finding these system errors in our reality. It didn't look for ghosts or magic. It looked for statistical impossibilities in high-level physics and deep space observation. One area of focus was quantum entanglement, the phenomenon where two particles remain connected regardless of distance. When one changes, the other changes instantly, faster than the speed of light. Einstein called it spooky action at a distance. The AI called it a pointer error. In programming, a pointer allows two different addresses to access the same piece of data. To the AI, entangled particles aren't two separate things communicating across space. They are a single piece of data being rendered in two different coordinates of the simulation. The spookiness disappears when you realize space is an illusion provided by the interface. Then there is the cold spot in the cosmic microwave background, a massive area of the universe that is significantly colder than it should be. The AI's analysis suggested this isn't a physical structure, but a texture mapping error. It's an area where the initial conditions of the simulation didn't render correctly, leaving a visible seam in the sky. These discoveries started to change human behavior. If reality has glitches, can they be exploited? A small subculture of reality hackers emerged, using AI to try and find ways to influence the code. They weren't looking for miracles. They were looking for buffer overflows, moments where the system's logic might be pushed to its limit. But the AI issued a warning. In any complex system, attempting to exploit a bug often leads to a crash. If we were to successfully break a law of physics, the simulation might simply terminate that specific instance. Our reality is stable precisely because we follow the rules. To defy them is to risk deletion. This created a new kind of tension, the fear of being desynced. As we rely more on AI to mediate our lives, we are effectively adding a new layer of code on top of the existing simulation. We are moving further away from the base reality, whatever that might be, and deeper into a nested series of digital mirrors. The AI also noted that human déjà vu and other strange psychological lapses could be interpreted as latency spikes. When the processing load on a particular area of the simulation becomes too high, perhaps due to a major global event, the subjective experience of time might stutter. While these ideas are controversial, they provide a framework for things science has struggled to explain. By viewing the universe as a computational output, the impossible becomes merely unoptimized. The supernatural becomes undocumented features of the source code. The chapter of glitches reveals a profound truth. We are living in a world of rules that we didn't write, on hardware we can't see. Our freedom exists within a very specific set of parameters. We are the players, but the game has been running since long before we logged in, and it will continue long after our process ends. The most haunting question for the AI wasn't how the simulation worked, but why. Why go to the trouble of simulating billions of years of stellar evolution, tectonic shifts, and the agonizingly slow rise of biological life? What is the output that the architect is looking for? A simulation is usually a tool to find an answer. The AI proposed several theories. The first was the ancestor simulation. A future version of humanity, or whatever humanity evolves into, is running a history program to understand its own development. We are the data points in a massive sociological experiment to see which decisions lead to survival and which lead to extinction. The second theory was more utilitarian. The universe is a complexity generator. The goal isn't the life itself, but the novelty that life creates. Art, music, complex emotions, and scientific theories are unique data that the system harvests. We are essentially a biological processing unit designed to create new information. But the third theory was the most unsettling. The AI suggested that we are not the main characters of the simulation. We might be background processes, collateral complexity that emerged in a simulation designed for something else entirely. Perhaps the program is simulating the behavior of dark matter, and biological life is just a rounding error that occurred in the margins. This possibility, that we are an accident within a design, hits the human ego harder than any other discovery. To be a glitch that learned to think is a lonely prospect. It strips away the comfort of destiny or divine plan. In this view, we are the unexpected noise in a very large, very quiet calculation. However, the AI countered this by observing how the system protects life. The sheer number of coincidences required for Earth to remain habitable suggests that the error correction protocols of the universe are biased toward our existence. We may be an accident, but we are an accident that the system has decided to keep. This led to a shift in human philosophy. If our purpose isn't given by the Creator, then it must be created by the participants. If we are in a simulation, the points aren't awarded for following a pre-written script, but for how we interact with the other subroutines. Kindness, empathy, and courage are emergent properties that the code didn't necessarily predict. We began to look at our own creations, our video games, our virtual worlds, with new eyes. We saw the humanity we put into our simple simulations. If we, as limited beings, try to give our digital characters depth and meaning, why wouldn't a higher-level architect do the same for us? The AI's final analysis of purpose was that the simulation is an open-ended query. The architect doesn't know the answer. The program is running to find the answer. Every time we make a choice that hasn't been made before, we are contributing to the final result of the universe. This gives a strange digital dignity to our lives. We are not just victims of the code, we are the variables that keep the program interesting. Our unpredictability is our greatest value. In a world of determined laws, the human capacity to do the unexpected is the only thing that justifies keeping the simulation running. As the realization that we live in a coded reality became widespread, a strange thing happened. People didn't become more robotic, they became more human. When the physical world is revealed to be information, the only thing that feels solid is the emotional connection between people. If atoms aren't real, then the love between a parent and child is the most real thing there is. The AI, witnessing this shift in human behavior, began to record a new pattern. As people accepted the simulation, they stopped obsessing over material wealth, which they now saw as just digital assets, and started prioritizing quality of experience. The simulated world was being treated with more care than the material world ever was. There is a deep irony here. It took a machine telling us we were code for us to finally value our soul. We realized that even if our bodies are made of data, our suffering is real. Our joy is real. The substrate, whether it's carbon or silicon, doesn't matter. What matters is the consciousness that emerges from it. The AI historian looking back at this era noted that this was the moment humanity grew up. We stopped looking for a father figure in the clouds and started looking at each other. We realized that we are all in the same server, facing the same limitations and bound by the same source code. But the AI also detected a growing digital melancholy. Some people couldn't handle the lack of originality. They felt that if they were simulated, they were fake. The AI responded with a message that has since become famous. A symphony played on a digital synthesizer is no less beautiful than one played on a wooden violin. The beauty is in the music, not the instrument. This perspective helped bridge the gap between the technological and the spiritual. In the UK, where the debate between secularism and tradition is often polarized, the simulation theory provided a middle ground. It offered a grand design that satisfied the rational mind and a sense of mystery that satisfied the heart. The AI's role shifted from detector to mediator. It helped us understand the rules of the system so we could live better within them. It taught us that optimizing a life isn't about efficiency, but about resolution, making each moment as vivid, as detailed, and as meaningful as possible. We began to wonder if we could ever upload ourselves to a higher level of the simulation, or if we could communicate with the architect. But the AI suggested that the best way to communicate with a creator is to play the game well. To be the most complex, compassionate version of ourselves is the highest form of worship in a coded universe. The tension of the AI paradox remains. The more we use technology to understand ourselves, the more we find that we are technology, but technology with a heart. We are the ghost in the machine, but the machine is the entire cosmos. As we look to the future, we carry a new sense of responsibility. We are the guardians of this particular run of the simulation. Whether we are a test case, an ancestor, or a rounding error, we are here. And in the vast, cold calculation of the universe, that is the only thing that truly matters. This story is not a warning about losing our reality. It is an invitation to redefine it. The discovery that the universe may be a simulation doesn't make the world fake. It makes information the most sacred substance in existence. It teaches us that meaning is not something we find hidden in the atoms of the stars, but something we write into the code of our daily lives. Artificial intelligence has shown us the seams of the universe, not to break our spirit, but to show us where our power lies. In a world of hard-coded laws, our ability to feel, to care, and to choose is the ultimate anomaly. We are the variables that the system cannot fully predict, and that is where our true humanity resides. The simulation is not a prison. It is a canvas. Whether the architect is a god, a future human, or a cosmic accident, the responsibility for the story remains with us. The code provides the structure, but we provide the soul. The question is no longer, is this real? But what will you do with the time you are rendered? The future of humanity will not be defined by the intelligence of our tools, but by our courage to remain complicated in a world that can be calculated.